Okay, this is the second e-learning assignment for Geometry Basic, in which we're going to work on pages 4, 5, and 6 from the area and perimeter note packet. First off, on page 4, the problems are fairly easy. I'm not going to do any of them, but I'm going to offer some hints for them. Here, this is a checkerboard, and it says the area of the whole checkerboard is 64 square inches. What is the area of just the black squares? Well, there's like 5 different ways to do this, but I want to point out the easiest way to do it is to take note that half of the squares are black. So if the whole thing is 64, use the idea of a half to find the how many of the area of the black squares. Problems 3 and 4 are kind of reverses of each other. In problem number 3, it says this pentagon is made up of 5 congruent triangles. That means each of these triangles has the same area. The area of the whole thing is 30, so what would the area of each of these be? What would they have to be if they're all the same? There's 5 of them, and they got to add up to 30. Well, in this case, for problems 3 and 4, you're going to be working on multiplying or dividing the areas. Here, problem number 4 is kind of the reverse of problem number 3. I'm telling you the area of each of these little triangles would have to be 15. So what's the area of this whole hexagon? You find it quickly by multiplying or dividing. And problem number 5 here, we have this, what's called a floor plan for a house. We have this house here, and if anybody's ever been involved or seen a house being renovated, one of the things people like to do is knock down walls. Here, we have 4 rooms with a bunch of separate areas, and what I want to do is I'm going to say they're going to knock down all the interior walls. That means they're going to get rid of that wall, and they're going to get rid of that wall, and just make one gigantic room. What would be the area of that room? Well, the key is to use these 4 areas and put them together to find the total area. The point of this whole page is to let you know that you can add and subtract and multiply and divide areas. Now, in some of these problems, in the first one, you should probably have divided your area. And this numbers 3 and 4 are multiplication and division problems as well. Problem number 5 here, we're simply going to add up the areas of those rooms. Problem number 6, subtraction is one of the confusing ones. Okay, and in this problem we're doing an estimate. The area of this floor of this room is 100, which we get by just doing 10 feet long by 10 feet wide, length times width. Now there's a carpet here, and I want you to just do an estimate, and so there isn't really a set right or wrong answer here, but give me an estimate of what the area of this rug is. Now just look at the picture, should have an idea. We should know that it's less than the total area of the room because the carpet is smaller than the floor. And I'll leave it to you to judge whether the carpet is taking up more or less than half of the floor. If you think the carpet's taking up exactly half, then you should be able to give me a nice round number here. If you think it's taking up more than half, then your answer should be more than half the area of the room. But I'll leave you to come up with your own estimate for this problem. On page 5, problem number 7 is a subtraction problem. We see this room, it's the same room as the last problem, 10 feet by 10 feet, so the area of the whole room is 100 square feet, which it says here. Now, there's a hole in the floor, so this part of the area is now missing. So I want to know what's the area of the parts that's left. Well, the area of the parts that are left is 85 square feet, and if I want to know how big the hole was, well, it's the gap between these two numbers. The whole thing's 100, and the part that isn't a big hole is 85, and what part is the big hole? And the idea here again is that area can be added, and in this case subtracted, or multiplied and divided. Okay, so some of our problems take a little bit more work, a little bit of calculation. Here, for this shape, we want to find its area and the perimeter. Now this is a composite shape, which you answered something about a couple of pages ago. And to find the area of a composite shape, we're simply going to add the parts. People tend to make some weird mistakes here, so let me offer some tips. What you want to do is you want to break this up into a couple of simple shapes whose areas you can easily find. For example, if I cut off this part here, this is a rectangle. Length is 18 and the width is 20. You can multiply those together to find that area. I'm going to do the same thing down here. Cut off this little square here, that's 10 by 10, and that little area is going to be easy to find. The one that causes people the most trouble is this one, this big rectangle here, because people use some of the wrong numbers to find this area. To find this area, we need one measurement, but this side we know it's 40. It says so right there. This length from here to here is not 80 though. 80 includes this last bit over here on the left that's not part of this rectangle. So this part is 18 short, so to find this length, we're going to take 80, the full length of the side, minus 18, the length of this room. And that'll give us the length of this blue room, which we then multiply by 40 to find the area of the blue room. Then, to find the area of the entire house, we simply add the area of this room plus this room plus this room. That'll tell us the area of the whole house. Next in this problem, we have to find the perimeter. But as we talked about before, perimeter is just the distance around the object. So we're simply going to add up the distances here. As you walk around it, that's 80 and 20 and 18 and 20 and 30 and et cetera, et cetera. I'll let you finish that to find the perimeter for this object. And this is the harder problem. The easier ones are below, the ones you'll have to do on your own. So why don't we take a moment and check those as well. Now, perimeter is very easy, so we're not going to worry too much about perimeter. We're going to focus on just area for these three problems. The way to find their area for all of them is basically the same thing. Break it up into smaller shapes whose areas are easy to find. Now, first off, what we want to do is you have to recognize that this number got cut off on your paper, which is originally supposed to be a 10. You'd have to add that in. That's not on your paper. It's cut off on mine as well. That's supposed to be 10 over there. All right, so if I want to find the area of this composite shape, I want to break it up into two rectangles. Everything's going to be rectangles. I can either draw a line across here, and I find the area of this rectangle up here and this rectangle down here, and then add them up. Or I'm going to draw a line here. In this case, I have a rectangle on the left and a rectangle on the right, and I'm going to add those areas. I'm going to do it this way, but you should get the same answer either way. And there's one extra trick you got to worry about. First off, let's worry about this one. This rectangle, its length is 8 and its height is 10, so this thing's going to be really simple. 8 times 10 will give us 80 for the area of this one. This one over here is a little bit trickier because we know the height or the width is 7, but we don't know this length right here. This length is unknown, but we can easily find it from looking at the picture. See, the distance all the way across this whole distance is 12, same as it is up here. So that distance has to be 12. This part from here to here is 8. So this missing part that we want has to be whatever I add with that 8 to get 12. So the 8, this length, plus the unknown have to add up to this 12. So to find this missing length, we'll just do 12 minus 8, and this missing length is 4. So the area of this rectangle is simply 4 times 7, which will give us 28. And then to find the area of the whole thing, we will simply add those two together. The other problems, you can do the exact same thing. I'd recommend in the second one, cut them off this way, and second and third one, cut them off left and right. So you got a rectangle on top, rectangle on bottom, add the areas. And the last one, draw lines here and here, find the areas of each of those three separately. No, and then add them up. The last part of your assignment is shapes with holes in them. And again, we're finding the area. For these, what we have is we have this big gray rectangle, and this little white rectangle has been cut out of it. This is like the room with the hole in the floor, where you simply subtracted the areas to find the resulting area. So in this case, that's exactly what we're going to do. We're going to find the area of the big rectangle here. So I'm going to find the area of this big rectangle by multiplying base times height, or length times width, 6 times 8. And then I'm going to subtract the area of this little rectangle inside. You got to find the length and width of this thing, but you're simply taking off 1 centimeter on each side. So instead of the whole height being 6, this little part of the height, subtract 1, subtract 1. So this part of the height will only be 4. And this length, instead of being 8, we subtract 1 on each side, it'll be 6. And I'll find the area of that big rectangle, again, 8 by 6. And I'm going to subtract the area of this little rectangle, which is now 4 by 6. So find the area of the big one, find the area of the little one, and subtract them. You do the same thing here in this problem. Find the area of the big square, easy, 9 times 8. And then you're going to subtract the area of that funny little L shape, and the resulting area is the gray bit. So for these problems, find the area of both the shapes, subtract the whole, the little part, the missing part, from the area of the bigger part. And finally, the last problem we have here for this assignment is we want to find the area under this curve. Finding an area under curve is really hard. We don't have a formula for it, just weird curve, what we to do to find the area. So instead, what we do is an estimate. And eventually, when you take, if and when you take calculus, you get an exact value by making some adjustments to this. But here's the basic idea. If I want to know the area of this gray part, instead of finding the area of a curve, I'm going to break that curve up into a bunch of little rectangles. What we'll do is we'll find the area of this rectangle, and this one, 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 and we'll simply add them together. That area should give us an approximation, an idea of what the area under the curve is. See, the rectangles aren't perfect. Here's a little bit too much, and then a little bit too little, a little too much, a little too little. But what we hope is that it gives us a good estimate. The way we'd make our estimate better is by finding the area of, we break it up into much more rectangles. And in calculus, you put an infinite number of tiny rectangles in here and add those areas, and that's how we find the actual value. You don't have to do that. For us, we're just doing length times width. For example, this first rectangle, this length from 1 to 2 here, that's 1. Its height, you can just look over across here, the height is 2. So if I want the area of this rectangle, I'm just going to do 1 times 2, and this one is going to be 2. And I go on and find the area of the next one, and the next one, and all of them, and then simply add them up. If you do this correctly, your answer will be a little bit more than 50. All right, that should be it to complete the second e-learning day assignment. You should now have pages 1 through 6 done in your note packet.